How are you all? Hope you all are utilizing your time in studies while being safe at home. So let's start with our next topic in chemistry class, in which we shall discuss about ionic compounds and their properties, and later on we'll be talking about occurrence of metals. So let's start with the class.
So let's start with today's class. Ionic compounds, a chemical bond formed between two atoms by a complete transference of electrons from one atom to another in order to complete their octets and thus acquire the stable nearest noble gas electronic configuration, is known as ionic bond or electrovalent bond. The number of electrons lost or gained by the atom is called its electrovalency. The compounds thus obtained are known as ionic compounds or electrovalent compounds. See children, if you remember, in the previous lecture I had discussed with you how metals and non-metals combine with each other. Those were all the examples of ionic bonds. If you remember, I told you also that ionic compounds, the properties we are going to discuss in the next class. So today we'll be talking about the details of the properties of ionic compounds. So the compounds formed by the transference of electrons from a metal to a non-metal are called ionic compounds, and these are also called as electrovalent compounds. Now, to discuss the details of properties of ionic compounds or electrovalent compounds, first of all, physical nature. They are solid and hard, generally brittle. Please, I am explaining you. Try to understand what do we mean by the physical nature of ionic compounds. See children, most of the ionic compounds are crystalline solids. Ionic compounds are relatively hard because of the strong electrostatic forces of attraction between the oppositely charged ions, that is positive and negative ions. These compounds are generally brittle and break into pieces when pressure or force is applied. We can do the experimental verification of this property here. See, take samples of sodium chloride, potassium chloride, or any other salt from your science lab. We'll be going to the lab and doing this. We observe that all are solids and are brittle. So, what do you mean by crystalline solids? Crystalline solids are the solids in which the constituent particles have a regular arrangement in the three-dimensional space. The regular arrangement of the ions in the three-dimensional space is called a crystal lattice. For example, sodium chloride has a cubic lattice. The figure is given in your NCERTs. You can see those figures that cube lattice, or the you may say cubic lattice, is formed. Now, melting and boiling points. They have high melting and boiling points. This is because in the ionic compounds, the oppositely charged ions are held together by strong electrostatic forces of attraction. Thus, a considerable amount of energy is required to cut off the strong inter-ionic forces of attraction and break them into ions. Here also, if we want to experimentally verify it, you can take a small amount of any of the salts and maybe in a test tube, and maybe in any other Pyrex, dry Pyrex kind of apparatus which can withstand with high temperature. Hold it in a test tube holder and heat it over the burner. You can observe it that melting of these salts is very, very difficult, which shows that they have high melting and boiling points. Now, the third property is solubility. Ionic compounds are generally soluble in water, which is a polar solvent, but insoluble in organic solvents like benzene, alcohol, ether, kerosene, etc. Experimental verification for the solubility: shake the samples of the salts in water, alcohol, petrol, kerosene oil, taken in test tubes separately, and you can observe that the salts are soluble in water but are insoluble in other solvents. So children, here you have to remember that the solubility of ionic solids in water is due to the polar nature of water molecules. The water molecules attract the oppositely charged ions of the ionic solid, which weakens the forces of attraction between the ions. Thus, the ions are surrounded by water molecules and are said to be hydrated. The next property here is the conduction of electricity, which can be called as electrical conductivity also. The conduction of electricity through a solution involves the movement of charged particles. Ionic compounds in the solid state do not conduct electricity because the oppositely charged ions are held together by strong electrostatic forces of attraction and are not free to move due to their rigid structures. When dissolved in water, ionic compounds dissociate to produce free ions in the solution. Similarly, on melting the ionic compound splits to produce free ions in the melt. Since ions can conduct electricity, thus ionic compounds conduct electricity in the aqueous solution or in the molten state. For this also, you can experimentally verify it. You just have to take a beaker and dissolve any of the salts into it, and you just have to set a circuit in which you will be taking two electrodes attached to the positive and the negative terminal of the battery. Put a bulb and a switch to this connection, and on switching the current, the bulb starts to glow, which indicates that the salt solution conducts electricity. Here, children, we can talk about one more property, that is ionic reactions. Since ionic compounds form free ions in the solution, thus reaction between two ionic compounds means the reaction between their ions. Since oppositely charged ions combine very quickly, hence these reactions are quite rapid. So this is how we talked about the properties of the ionic compounds. Now let's talk about something about occurrence of metals. Children, try to understand one thing. Metals occur in nature in various forms. These are found in nature either in the free state or native state, that is as free elements, or in the combined state, that is in the form of their compounds. The least reactive metals such as gold, platinum, silver and copper, which are at the bottom of the reactivity series in the free state. They are in the free state, that is the free elements, while the highly reactive metals such as potassium, sodium, calcium, which are at the top of the reactivity series, are never found in the free state but are always found in the combined states. The metals in the middle of the reactivity series such as zinc, iron, lead are also generally found in the combined state. Copper and silver being at the top of the metals at the bottom, that is just below hydrogen, are found in the free state as well as in the combined state as their sulfide or oxide ores. Here you just have to understand something very important, that the earth's crust is the major source of metals. All the metals are generally found in the earth's crust. So we have to extract those metals from their ores. And here you have to understand two terms very important for the metallurgy. One is mineral and another is ores. Try to understand, children, what are minerals. The elements or compounds which occur naturally in earth's crust are called as minerals. And ores are the minerals that contain very high percentage of particular metal, and the metal can be profitably extracted from it. Such minerals are called as ores. So here the most important statement you have to understand here is, all ores are minerals, but all minerals are not ores. It is interesting to note here that most of the metal ores are oxides, because oxygen is a very reactive element and is very abundant on the earth. You can have few examples of ores. See children, if we talk about a metal sodium, so the name of the ore through which we are going to extract sodium is rock salt. And similarly, dolomite is the ore of calcium, bauxite is the ore of aluminium, copper glance, copper pyrite is the ore of, these are the two ores of copper, zinc blende for zinc, and so on. So you just have to understand that we have to extract metals from their ores. That we'll be talking about in your next class, that is metallurgy. So extraction of metals from ores will be discussing under these three headings. First of all, how the enrichment of ores is done, then how the metals are extracted, and later we'll be discussing about the refining of metals.
For today, children, I hope whatever was explained in today's class, you must have understood it nicely. If you have any doubts, you may ask any number of times. God bless you all.